I'm going to go through solutions for each of these surface area problems. But if you're watching this and you haven't tried this one on your own first, this is something we've already learned. It doesn't require extra instructions. I'll remind you that every formula you could possibly need is up here, but I'll also acknowledge that many formulas you do not need are up there, which presents you the challenge of choosing the correct formulas. But try each one of these on your own. Only watch this video after you've tried to find the surface area of each one on your own. If you're having trouble getting started on one, though, you can use the video to help you remember how to get started. And this might be the #1 candidate since it's the first one. Find the surface area. The figure is a regular pyramid. They're telling you it's a regular pyramid to tell you that the base shape is a regular, in this case quadrilateral, which must mean that it's a square. So if this edge is 10, this edge is 10. And so I'm going to label the square as face A. They tell you the base is a regular polygon. That's how we knew that was a square. And the lateral faces are congruent isosceles triangles. So each of these other faces, each of these triangles is congruent. And so I only need to label face B for the triangles. Let me draw one of these triangles, which we've labeled face B. It has a base of 10 centimeters, and the height is shown from the vertex to the base. Perpendicular distance from the vertex to the base is 12. And so if I'm finding the area of face B, I use the formula for a triangle, which is given right here, 1/2 base times height. So the area of triangle face B is 1/2 multiplied by a base of 10 and a height of 12. Half of 10 is 5, and 5 times 12 is 60. So the area of face B, the area of any of those triangular faces, is 60. They're all congruent. The area of face A, the square, the 10 by 10 square, is of course 100, because any parallelogram is base times height. For square, it's just side times side, since the base and the height are congruent. And so we get 10 times 10, or 10 squared, and that's why it's called squared, 100. Remember, when we learned surface area, we wrote a formula, and it differs from one polyhedron to the next, because you'll have different numbers, different quantities of congruent faces depending on what kind of polyhedron you're looking at. In this one, we have one square base, so one area A, and 4 congruent isosceles triangles, so 4 area B. So when I substitute the areas of the faces we've calculated, I get 100 plus 4 multiplied by 60, or 100 plus 240, is 340 centimeters squared. Remember that even though this pyramid is certainly 3-dimensional, area is the amount of 2-dimensional space taken up by each face, and so the sum of those, the areas of those faces, will also be a 2-dimensional measurement, which is why we say centimeters squared. 340 is right here, so the way this puzzle works is you can't do anything until you've solved them all. So just circle B, circle 340 on your paper. Try the next one on your own and then use the video.